first property we have, the multiplication property. If you have a log of two things being multiplied together, it said we could do their individual logs and do what? Add them. So you have to write the log base 7 with each, so it becomes log base 7 of 8 plus log base 7 of 6. On B, if they are divided, what do you do?
Subtract.
You always subtract off what's on the bottom. So it's log base 6 of 12 minus log base 6 of 5. Okay. C. Log base 2 of the cube root of 9. Keep in mind, that's the same thing as saying 9 to the 1/3 power. What do we do in that case? What was our power property? Exponent becomes coefficient, so it's 1/3 log base 2 of 9. So those were the three properties, and then we're just going to continue using them. If I said log base A of the 4th root of r cubed, log base A. E. Okay, so I threw a little more into this one. A square root is like what power? What? 1/2. So this is all to the 1/2 power. If I wanted to simplify it a bit more, I could distribute that 1/2 to each of them. So we have an r to the 3/2. S, 2 times 1/2 is just 1 over t, 4 times 1/2 is 2. Then let's break this apart. I'm going to go ahead and just do it all at once. So the r, the exponent would come down in front. So we would have 3/2 log base A of r. Essentially anything on the top of the fraction will be added in. So it'll be plus, s was just to the first, so that's log base A of s. T is on the bottom, so we would subtract, and the 2 would come in front, so minus 2 log base A of t. Did I lose you on this?
Yes.
Okay, where at?
Just separating now.
Okay. So if you have things multiplied, you could add your individual logs. So the s is multiplied, so we would add it. anything on the bottom gets subtracted. If you have multiple terms on the bottom, they all get subtracted.
So if there was like a something minus t, then you would.
If it's minus, we can't break it apart.
Or.
But if it was like v times t, we would also have a minus log base a of v. And so then I just went ahead and brought down my exponents.
I think you're just basically doing the opposite to get it all on the same
Yeah,
line.
we're just using those three properties to break it apart. So let's do some that are maybe a little bit up there. My x is multiplied with this radical, so what do? We log base a of x plus log base a. I could say the square root of that, or I could write it to what power? Then what would we do?
Would you break it?
We don't have to do that. What's our property with the exponents? Yeah, they turn into a coefficient. So it's log base a of x plus 1/2 log base a over x squared plus 1. We can break apart things that are multiplied or divided. Can I break apart things that are added? No, that's my final answer. I can't bring down this square because the entire parenthesis is squared. I can only bring down the exponent if it's applying to x. So B. How many logs are we going to have when we break this up? 3. We have 2 things on top and 1 on the bottom. So it'll be log of x plus log of x plus 2 So you can go ahead and bring down that 2 if you'd like. That was the only thing on the bottom. We can't break apart the addition, so that is as simplified as it gets. Why don't you guys take a second and try a couple? The square root is what kind of power? 1/2. And then what happens with your power? So we have 1/2 log base a of the x squared plus 1. Can I bring down my square? No, because I have something added with it. This is on the bottom, so minus 3 log base a of x. This is also on the bottom, so it also gets a minus. 4 comes down, log base a of x plus 1. Second one. We have the log base 2 of x cubed, so the x stays and the 3 comes down, minus log base 2 of the x minus 3. There is subtracted, so I can't break it up. Questions on those two? I'm gonna keep using these properties, but we're going to go the other way. I want you to write these as a single logarithm. So this time I've given you the broken apart version. You have to put it back together. So I want a single log. Anything with a positive goes on top, anything with a negative goes on the bottom. So this was a positive log, so the x goes on top. This was a negative log, so the y goes on the bottom. This one was positive, so it goes back on top. So it's just log base 4 of xz over y. Only write the log once.
So before how does it happen? To the power?
Yes. So this 4 basically tells me we have log base b of r to the 4 minus log base b of s to the 5th.
And then now we're gonna
So subtracting means divide. The r was positive, so it's on top. S was negative, so it's on the bottom.
So does that mean like the 1/3 means it was a square root or?
Yeah, a cube root.
A cube, yeah.
You are, and so on those, I don't mind if you write it as a radical or if you just want to keep it as an exponent, that's okay too. So
Okay.
if you wanted to write this as log base a of x to the 1/3 plus log base a of y to the 2/3 minus log base a of xy. That's
So
fine.
then we can just do on the top x 1/3 multiplied to y 2/3 over x and y.
Mhm. If you have any obvious simplifying when you get to this point, go ahead and do that. You know, if you want to reduce these x's, you can. If you have x's on top and bottom, what do you do with your exponents? Subtract them. This is like an x to the first. So that's bigger. 1 minus 1/3 is 2/3. Same thing with y's, we have more on the bottom. 1 minus 2/3 is 1/3. So you could simplify that to 1 over x to the 2/3, y to the 1/3.
We can count off if we don't.
If it probably, if I put it on a test or quiz, I'd probably give you something a little more obvious, like x cubed over x, and then I would definitely want you to. I'm gonna put a couple up here for you guys. So condense these into one logarithm. I'm gonna add a third one too. So the first one, all three of these are added. So we're multiplying together x times 9, so 9x times the x squared plus 1. Minus, so divided by 5. If you wanted to multiply out the top, you could, but you don't have to. You could do it like this. Yes.
I wrote it like that, but I just wrote like x times 9 and didn't just into it.
I wouldn't count it wrong, but we usually do write the coefficients in front. So it's not wrong, just not how we normally write it. B, we know this would be like a u to the third and a b to the fourth. They're added, so you multiply, so log base 5 of u to the third, b to the fourth. C, these are subtracted, so you divide. If you had wanted, you could have written like a square root is x to the 1/2. So if you did subtract exponents and you wrote this, I would also take that. Any questions on those? I'm going to put a problem up here. I want to evaluate without using a calculator. So log base 8 of 2 plus log base 8 of 4. You could, if you're thinking about yesterday, that means like 8 to what power equals 2, and you might know that. Or we could also use our properties. If these logs are added, what do? So this becomes log base 8 of 2 times 4, which is 8. What is log base 8 of 8? So keep in mind you can condense things first. This is just like saying 8 to what power equals 8. So it's just the first power. B, what would you do with those? Divide them. So that would be log base 6 of 18 divided by 3, or log base 6 of 6, which is, again, 1. So don't forget that you have those properties available to you. I'd like to do one last problem and then I'm done. I am going to tell you that log base 10 of 7 is equal to 0.8451. So we are going to use that, and using only that piece, I want you to evaluate these things. So if I said log base 10 of 49, and the only thing I know is log base 10 of 7. What did you do? 49 is the same as 7 squared. But properties of logs, what would happen to that squared? This is 2. Log base 10 of 7. And log base 10 of 7 is 0.8451. So multiply that by 2 and you get next one. could I rewrite 70? Seven times 10. And then we know we could add those log base 10 of 7. This log base 10 of 10. Log base 10 of 7 I told you was 0.8451. What is log base 10 of 10? We get 1.8451. Questions? There's a math Excel assignment open and you've got quite a bit of time to work on.